Okay.
So let's do that here. Hold on. I'm expanding my desktop here. So our equation is y equals negative 0.08 x squared plus 1.3 x plus 3?
Yeah.
Okay. So to complete the squares, we're going to isolate that.
Okay.
And then we have to turn this into an expression of x minus h quantity squared, and whatever number is left up over there is k.
Okay.
Okay? So, the first thing you have to do when you go to complete the square is to make sure the coefficient of the x squared term is 1.
Okay.
So how do I do that?
Wouldn't that be positive 0.08?
No. What we're going to do is we're going to factor that out of both of these terms. So I'm going to divide both of these terms with x by negative 0.08. What is the next term?
Plus 0.08?
Do you have a calculator?
Yeah.
We have to divide 1.3 by negative 0.08.
That would be negative 16.25.
16.25?
Yeah.
All right. Now, at this point, we haven't changed anything.
Right.
We still have our original equation. The only thing I've done is I've factored out a negative 0.08 from these two terms. When I divide that by negative 0.08, I got 16.25. So now we're in a position to complete the square. You can't complete the square until you get that coefficient to be equal to 1.
Okay.
So how do we complete the square inside the parentheses?
You FOIL it?
No, you take half of that coefficient
Okay.
and you square it. So tell me what that is.
66.01.
I'm going to add it. 66.01 right there. Now, what did I just do to the right side of the equation when I wrote in 66.01? How much did I change the right side by?
36? No, 63.
This times that. What is that?
Hold on.
0.08 times 66.01.
Negative 5.28.
Okay? So what I really did when I wrote that number in there is I subtracted negative 5.28 from the right side of the equation.
Okay.
So to balance that, I have to add 5.28 to the right side of the equation. Now it's important you see why we did that. When I arbitrarily wrote that number in there, what I was really doing to the right side of the equation was taking 66.01 and multiplying it by negative 0.08, and that's what I was doing to the right side of the equation. So I was really subtracting 5.28 from it.
Okay.
And since I'm not allowed to change the value on the right side of the equation, I have to now add 5.28. Okay, bringing us to this. In other words, this is still the same as this.
Okay.
Only thing is, we're now in vertex format. Notice vertex format is A times what?
A times, oh, I don't know. X minus H plus K.
Uh-huh. So, if we can write that as X minus H squared, we're home free.
Right.
Now, the whole reason you complete the square is so that you can do that. In other words, I can now write 8.125 quantity squared instead of writing it like that. And it's guaranteed that you can do this. In other words, that's the reason we take half of that number and square it and write it in there.
Okay.
Okay? And then the K is that, plus 8.28.
So it'd be minus, plus, never mind.
So there's our equation in vertex format. Assuming this is the correct equation from graphing. How many points did you have?
I had three.
Just 3?
Well, and plus the bird, so 4.
Okay. All right. Well, there it is in vertex format.
Okay. And then it says, what will the horizontal distance traveled be for the bird when it is at the height of 2 feet? So you just plug in 2 for y.
Uh-huh.
So that would be 2 equals...
And solve for x. Now the easiest way to do that here is to use the vertex format, I think.
Okay.
And here, let's do it. Let me show you how to do it. Just a second. So we're going to plug in 2 for y, because y is the height at any point in time, negative 0.08 times x minus 8.125 squared plus 8.28. How do we solve that equation for x? And it's much easier solving this for x than it would be if we were in standard format. What's the first thing I'm going to do?
Multiply 0.08.
No. We want to try to isolate that quantity. Because once I do, I can then take the square root of both sides. So I don't have to fool with factoring a quadratic or using the quadratic formula or anything. I got to take this 8.28 and put it on the other side. Now what?
Where did you get... Wasn't it supposed to be plus... Oh, never mind. I wrote that wrong.
Okay. So now we're down to this step. We're trying to solve this equation for x. So what's the next thing I need to do? Remember, we're trying to isolate that.
You square whatever in the parentheses?
No. Divide both sides by minus 0.08.
Okay.
Notice that if I divide the right side by minus 0.08, I'm going to get rid of that, and I'm going to be left with what's in the parentheses being squared. Since I'm doing it to the right side, I got to do it to the left side. What is 6.28 divided by 0.08?
I got 78.5.
Positive, because I have a negative divided by a negative.
Right.
So now I'm down to here. Now what can I do, the next step?
I don't know.
Take the square root of both sides.
Okay.
What's the square root of 78.5?
That'd be 8.86.
Well, and now that's going to be equal to that. In other words, when I take the square root of the right side, it's just equal to whatever was being squared.
Okay.
Now add 8.125 to both sides, and you basically get 17.
Okay.
So x would be 17 feet when the height of y was 2.
Okay. Cool.
Now, we did get two solutions, because actually it's plus or minus. When I take the square root of both sides here, this is plus or minus. Well, if I take the minus number and then add this 8.125, I'm still negative. And we can't have a negative distance. So we discard the negative answer and go just with the positive answer, and we get 17.
All right. Now on to problem 3.
Is that 3? No, that's 2. That's the one we did. That's 3.
Yeah. So it says the bluebirds go for breaking ice are named Jim, Jack, and Jay. The estimated equations for Jim and Jack are listed below, along with the positive 0 for his function. Okay. A. Write a quadratic equation for J in vertex form to model J's path, estimating his starting position is 0, 2.
I'm completely lost here. I do not know what they were looking for here. What do we have? We have Jim has his own equation, his own quadratic projectile path based on this equation. And Jake has a different equation, so he has a different projectile path. Is there an equation for J? I don't see it on here.
No, I think that's what we have to find. Because it says find it in vertex form.
What's the relationship between these three things? Why are they all being graphed on the same axis?
I don't know. It's like, have you played the game Angry Birds?
No, I haven't.
It's this thing where you catapult these birds to kill these pigs or something. I don't know.
Oh, it's like skeet shooting now. In other words, Jim is an angry bird that's been fired from a gun somewhere? Is this
like,
his vertex? What is this position right there?
That's where he's falling, and then you find the vertex, He's being shot by like
so
that.
Jim's vertex is 5.5, comma 9.5.
Mm-hmm.
And his 0 is 11.7 is where he's going to hit the ground.
Right.
Jake's vertex is 7.5 to the right of Jim, and the y-coordinate is 8.5. Okay, I'm getting that now. All right, J. All right, I think I understand now. In other words, we could have written these two equations almost by this. In other words, that shows us his vertex for Jim and Jake. And that gives you H and K. Now, you still have to calculate A, but they're giving us a 0, and they're giving us J's starting position. Okay. All right, let's see what we can come up with here. What's J's vertex? So J's equation is supposed to be, you should probably do this on every single one of these problems, is write the general formula. Mainly so you'll remember it. In other words, if you always start with the general formula, then when you get a problem like this, you'll know how to begin. If you don't know the general formula, it's awful hard. What do we know about J? We know his vertex, right?
Mm-hmm.
In other words, we know that vertex, we know that vertex based on these numbers over here. Well, J looks to be at an x-coordinate. Oh, man.
Those don't look like the vertexes, though.
No, they aren't, now that I look at it. No, Jake is like at 9.5 here, so his vertex is somewhere else.
Yeah. I don't know. This is just whatever. Stupid math teachers. I don't know what she's doing with her life.
This is pretty funky, I have to admit.
I have no idea what she was doing with this and why it's a project. I don't know.
So if we do know where to put Jim's vertex,
Mm-hmm.
and we know where to put Jake's vertex,
Mm-hmm.
and we see these 2 points here,
Mm-hmm.
and we know where their zeros are. In other words, where they're going to come down and hit the ground.
Right.
So I can graph Jim and Jake completely. Completely. And you're right, these points are not their vertex, but they've given us the equation so we can plot their vertex.
Right.
So I could draw Jim's parabola, I can draw Jake's parabola.
Mm-hmm.
J, on the other hand, is there any kind of relationship between J, Jake, and Jim? It says, model J's path, estimating his starting position at 0, 2. Well, that's right there. There's 0, 2. So it looks like J was shot into the air somewhere, has a vertex somewhere, and does something like that. But we're only given 1 point. We're giving his starting point, and we're given another point, and you need 3 points to make a parabola.
Well, can't you find, like, the axis of symmetry?
Only if I know something about that. In other words, here's what they're giving us. They're giving us the starting point of J, and they're giving us some point over there for J.
Mm-hmm.
Now, notice, I can draw all kinds of parabolas through those 2 points. I could draw this kind of parabola. I could draw that kind of parabola. I could even have a vertex going right there and draw that kind of parabola. So
Yeah.
from 2 points, I cannot come up with the equation of that parabola. So
Right.
I don't know what's going on here.
Yeah.
Was there anything under Jake, or is this the bottom of the page over here?
That's the bottom of the page.
Okay. And why did they give us the zeros? In other words, that allows us to fully graph Jim and Jake. So we could tell where Jim and Jake hit the ground. It says,
Yeah,
how much further does Jay fly before hitting the ground than Jim?
I don't know.
Jim hits the ground at 11.7. Jake hits the ground at 16. If we had an equation for Jay, we could figure out where he was going to hit the ground. But I don't see how we're going to find one based on 2 points.
Yeah, so we should just move on to the next one. Because my teacher's dumb. I don't even know if she knows what she's doing.
Is this the next one?
Yes, sir.
Okay. There must have been some writing or something before this. We're supposed to estimate the point of a pig on the x-axis.
It's the one that looks like an apple.
Oh, that's the pig?
Yeah.
Okay, what is a good estimate of that point?
I would say 16-0.
All right.
Write an equation of the axis of symmetry.
For any parabola going through the origin and hitting the pig from part A, write the equation of the axis of symmetry for any parabola. All right, well, the pig, something had to go up here and come back down to there, right?
Mm-hmm.
So the parabola, let me draw it. We have our pig at 16.
Mm-hmm.
And it started at 0. So it did something like this, or perhaps that, or perhaps that. So
Yes, sir.
we can write any equation we want. Hold on, let's see. Write the equation, for the axis of symmetry, hold on. The axis of symmetry is the one that goes right through the vertex of all three of those.
Right.
So what's the equation of that dotted line?
X equals, I don't know yet.
Well, look at my graph. It's halfway between the origin
So 8?
and 16, yeah.
Okay.
No matter which of those paths the pig took, its vertex is going to be halfway between where it took off from and where it landed.
Right.
All right. So write the equation. Okay, we've done that. Write the equation for a parabola in intercept form that would hit the pig from part A, but also through the point 10, 2 above the wall. That's right there.
Uh-huh.
Okay? So here's what they're saying. There's a point right here at 10, 2, and this parabola has to go through that point. Well, clearly it's come on the downside, right? Because the peak's going to be at 8. So that's not the vertex. Excuse me. That is the vertex, but it's not the point that the pig goes through.
Right.
So vertex format is what? Excuse me. X-intercept format is what?
Y equals X minus, or AX minus P times x plus q minus q.
Minus q. It's always minus.
Okay.
Whenever you're subtracting anything from x, it's always going to be minus that. Whether we're talking parabolas or conic sections, circles, ellipses, any of that, it's always going to be minus.
Okay.
Now, what's p and q?
X-intercepts?
Which are?
0, and 16.
So if we multiply that out, we get a times x squared minus 16x. That is the equation of this parabola.
Okay.
Only we need a. If I knew what a was, I would have the final equation of that parabola. Well, we do know one point that the parabola goes through, besides the intercepts. And you can't use the x-intercepts for either of these points, but you can use any other point. Okay, well, we have a point, 10, 2. So where do I plug that in?
For x? I don't know.
For x and y. In other words, if we plug in for x and y, we'll be able to solve for a. Because once I plug in for y and x, I'm only going to have one variable left in this equation. So the y coordinate is 2. Still don't know a yet. 10 squared is 100, because the x coordinate is 10, minus 160.
Okay.
So now we have 2 equals minus 60a. So a looks to be minus 1/30. So the equation of this parabola is minus 1/30 times the quantity x squared minus 16x. I suppose we should simplify that.
Yeah.
So that would be minus 1/30 x squared plus 8/15 x.
Okay.
So there is the equation in standard format.
Okay.
And hold on, let's see. It says write the equation in intercept form. So actually, let's go back up to here. That's intercept format right there. So if I substitute for that a, minus 1/30, that's the answer they're looking for. Only get rid of this x minus 0. It's minus 1/30 times x times the quantity x minus 16. That is the answer in x-intercept form.
Okay.
Write down the y value of the ground. What is the y value of the ground?
-1. -2.
Yeah, that's as good as anything. I mean, obviously the ground is not horizontal. It goes up and down in moguls here. So -1 is decent. What would the horizontal distance traveled be for the bird to land on the ground? Okay, here's the equation we're going to use. How am I going to solve for x? And x is the horizontal distance.
You plug in a point for y?
Which point? What is y? What is the ground on our chart?
-1.
Okay, that's what we plug in for y. In other words,
So -1 equals -1/30 x, right? Or are we using the x squared one?
X squared.
Okay. X squared plus 8/15.
And now we want to solve that quadratic equation.
Alright. So we set that to 0 instead?
Well, I had it set to -1, but then I took the 1 over on the other side, leaving 0.
Okay.
Because what we're trying to solve for is when that parabola is going to have a height of -1.
Okay.
And we do that by solving this quadratic equation.
Alright.
I suppose the best thing to do here would be to multiply every term by 30, by -30. So that'll make x squared minus 16x minus 30.
Okay. Then do you divide by 2?
No. Where are you getting 2 from? Where are you getting 2 from?
Well, I was going to say square root them all so you get rid of the x squared.
No, you can't do that. Not unless we complete the square and do it. I'm sitting here trying to figure out if that factors. I don't think it does. Factors of 30 are 6 and 5, 10 and 3, 15 and 2, none of which subtract to the number 16.
Nope.
Which means the solution lies in the quadratic formula.
Okay. Is that a 1?
Yeah. What is 16 squared plus 120?
What's the question again?
We have to figure out what the inside of that radical is. So we have to square 16, and then we have to add 120, 4 times 30.
376.
Okay, so now x is equal to 16 plus or minus the square root of 376 all over 2.
Alright.
And we probably are going to take just the plus answer. What's the square root of 376?
19.39.
So we're going to add that to 16, giving us 35.39. Divide that by 2, that's your answer.
17.69.
Now the question is, does that make any sense? Yeah, in other words, at present, here's the path that's hitting the pig. It's going up, right there. There's our axis of symmetry. That's where our vertex is going to be. It's coming down. It's coming down. It's going to land right on the pig. But it said, where would it hit the ground if it kept going? Well, the ground is right there at 17 whatever.
Okay.
So the answer makes sense.
Right.
And on problems like this, where you've got all these fractions and decimals and stuff, that you should do that check, because it's easy to get way off.
Okay.
All right. All right. So we're done with that page, it looks like?
Yes.
Is that one there? No. This was the one we didn't know how to do because I don't know how to do that. All right, this is the one we did. Let me get this up there. Is this the next one?
Yep.
Okay, we have a quadratic function where h of t is the height of the object at any given time.
Right.
H sub 0 is its initial velocity, h sub 0 is its initial height.
Right.
So A says, when launching a bird into the air from a starting position of 3 feet, that means h sub 0 is 3, it takes the bird 4.2 seconds to reach the ground. Find out what the initial velocity is. Okay, so here's our equation. H of t equals minus 16t squared plus v sub 0, the initial velocity, plus 3. Because it tells us that the bird was launched from 3 feet above the ground. And it says it takes 4.2 seconds to reach the ground. So I know that 0 is going to be the height of the bird after 4.2 seconds, right?
Right.
So I'm going to plug in 0 for that. I'm going to plug in 4.2 for t. And I'm going to solve for v.
Okay.
In other words, I now, boy, whatever you did, fix the sound. What were we, what, I don't know, it went from horrible echo to perfect. So now we just have to solve this for v sub 0. So let's practice your algebra here, Taryn.
Right.
How do I solve that for v? Trying to isolate this.
Subtract 3 from both sides.
Okay, that's a good start. Now what?
Hold on. So then you multiply negative 16 times 4.2 squared.
PEMDAS. What do we do first? Square it or multiply it? Notice the square, the 2, does not apply to the 16. It only applies to the 4.2.
Right, so then you square that times negative 16.
There you go. In other words, you got to square it first. You can't multiply the 16 times that before you square it. So square that. What does that equal to?
That is 17.64.
Multiply it by 16.
17.64 times negative 16. It'd be negative 282.24.
Plus v sub 0 times 4.2.
Yeah.
Well, if they really want somebody to hate math, this is the way to do it.
Yep, pretty much. Sounds like my teacher.
No, so I'm serious. If you really want somebody to hate math, just throw in problems that have all these decimals and fractions and just make it so hard that and boring. Okay, so now what do I do?
You add to 82.24 plus 3.
To a minus 3. So that makes it 279.24 on the left side of the equation. On the right side of the equation, I have v sub 0, 4.2. Well, if I write that more typical, I'm going to put the 4.2 in front, correct?
Yeah.
Now solve for v sub 0. How?
You divide by 4.2.
Go ahead.
would be 2 divided by, hold on, okay, 279.24 divided by 0.2, 66.48.
And that is in feet per second. Feet per second, I imagine. Doesn't tell you what the things are on that. So that's the initial velocity of the bird, 66.48.
Right.
All right, B, write an equation for the height of the bird in terms of time. Well, here was our equation. The only thing missing was V sub 0.
Okay.
Plug in V sub 0 in place of this V, in other words, plug in 66.48 in place of V sub 0, and there's your equation.
Okay.
In fact, let me
16t squared plus
66.48t. Okay, so there's the equation of projectile motion for this bird.
Okay.
I'm going to erase all of this. And now their last question. Okay, so that's the equation for the height in terms of time.
Right.
Okay. So number 6. Write down 3 points along the bird's path. Estimate, what's the rest of that say?
Oh, there's part C on that last problem. Did I cut it off by the teacher at all?
No, you didn't. I was cutting it off accidentally. Okay. So if this is our equation, well, finding 3 points along the bird's path, relatively easy. 3 points define a parabola.
There's a part C on number 5.
I see it. We're doing part A?
No, we're on the other side. That's problem 6.
That's why I wasn't understanding what you were saying. I got you now. If the bird is launched straight up, how long would it take to hit a pig hovering 50 feet above the ground? Well, what was its initial velocity?
66.48.
So if the bird is launched straight up, then how long does it take to hit 50 feet, is what they're saying, a height of 50 feet. So again, we plug in 50 for the height and solve this ridiculous quadratic equation. You want me to do it on Wolfram Alpha?
Huh?
Do you know how to solve that equation? Again, I got to move the 50 to the other side. And solve that quadratic. Now, you can do this by using the quadratic formula, or I can do it on Wolfram Alpha and we'll get the last laugh.
All right.
Hold on. So, minus 16 x squared plus 66.48x minus 47 equals. They automatically set it equal to 0. Now the two zeros are, in other words, it would hit the pig at, hold on a second, maybe they don't automatically set it. Let me set it equal to 0 and see what the two times are. So it would hit the pig going up at 0.9 seconds, and it would hit the pig coming back down at 3.25 seconds. But the answer is going to be this, because presumably if you hit the pig, it's going to fall out of the sky, so it wouldn't hit it on the way down. But basically, what we've done is solve.
So it would just be not 0.9?
How many
It would just be the point.
How many decimal points do they want it? I don't know. I would say 0.903 maybe. Depends on how many decimal points she wants.
Alright. That's fine.
Now, and that makes sense. Notice that the velocity is 66 feet per second. So if the pig is only 50 feet in the air, then we should hit it in under a second.
Right. Okay.
I guess you got gravity working against you, but all right. So now shall we go to 6?
Yeah.
Okay. Write down 3 points along the pig's path. Estimate whole number ordered pairs. Thank goodness. As far as I'm concerned, that's the worst part of this lesson. Is putting all these ridiculous numbers in it. That just makes it hard and boring. I mean, why can't they use numbers like 2, 3, 4, 6, 8, you know? And then we understand what's going on. But to do it with these crazy numbers. All right, here was our equation right up here. Okay? So, how do we figure out 3 points along that path?
I don't know.
Well, let's try a t of 1, a t of 2, and a t of 3.
Okay.
So what is h of 1 equal to? Well, minus 16 plus 66.48 plus 3. So h of 1 equals 53.48. Estimate whole numbers. Okay. That whole number is going to be 1 comma 53.
I don't think it has anything to do with the equation that we just found.
Is this a new problem?
Yeah.
Oh, because the other problem was, no, I think it's the same problem. This is launching a bird into the air.
It says number 6. It's a different problem.
Okay, I get that.
Yeah.
Okay, so
I think we just find
give us
points
the
on the
equation or anything. Oh, I see. Write down. Okay, I got you. Okay, and then we're going to put it into your calculator and figure out the quadratic regression. All right, I'm with you now. So pick 3 points that are reasonably close to whole numbers. In other words, there's a whole number on both grid. It's awful hard to read this grid when they put all this garbage in the background.
Yeah. I said 0, 4 for 1 point.
Is that right here?
Down 1.
Is this the x-axis? Yeah, that's the time axis. So that point is 1, 2, 3, doesn't look like 4.
Well, the bottom is like, it's really faint.
Okay.
It's like...
Whatever.
Yeah.
That's fine. Go ahead and put that as 1 point.
Alright, and then another one would be...
Let's try to find a point that crosses where it's whole numbers for both of them, like right there. What is the x-axis position right there? Looks like 2, 4, 6. What's the y-coordinate?
6.
No, it's much more than 6.
No,
Where my hand
6.
is? Where this little hand is?
Yeah, where the x is, that's 6.
That's 6 on the x-axis. What's the y-coordinate? I'm afraid to take my hand off to count because...
10.
It's 10? Okay. So another point. So you got 0, 4. 6, 10. And let's pick another point that goes through a corner. How about that one right there? What's that point?
That is, let's see, 16, 1, 2, 3, 4, 5, 6, 16, 6.
Okay. All right. Since 3 points is all you need to define a parabola, if you put in only 3 points into a quadratic regression, it's going to give you a perfect parabola for that. In fact, should have an r squared of 1.
Okay.
And you know how to do this in your calculator?
Yeah, I'm doing it right now. And then 4. I got negative 0.08
For A?
x. Yeah.
What for B?
1.52.
And C?
4.
So what's the equation?
Y equals negative 0.08 plus x squared, right, yeah, plus 1.52x plus 4.
And r squared is equal to...
16.
Really? On your calculator, it didn't tell you what r squared?
Oh, no, it didn't.
It didn't give you an r squared?
No.
Here, just a second. I did a quadratic regression on my calculator earlier based on one of your other tables. But, of course, if there's multiple points, r squared is not going to be... Should be the line under C on your calculator.
It doesn't show up on mine. I don't know why.
Okay. Well, because there's only... Notice what a quadratic regression means. If I have only 3 points, there is only one quadratic that can fit through those 3 points.
Gotcha.
Which means it's going to be a perfect regression line. There is not going to be any distance at all between my 3 points and the quadratic that I've come up with, because I can fit a perfect quadratic through any 3 points. So that correlation coefficient that they're talking about in C should be 1. And if I did it on my calculator, I think it would come out to be 1. Now what does that tell us about the quadratic regression line? It's perfect, I guess, is what they're looking for, assuming it comes out to be 1.
Okay.
All right. That was painful.
Yeah.
I'm just kidding. Who am I?
I can do the last one on my own.
Okay. Well, yeah, we're out of time, and I have a 7 o'clock, so.
I have a question. Are you free by any chance tomorrow at like 6? By any chance?
There's my Tuesday right there.
Oh, and you're not. Darn.
Wednesday isn't much better.
Wednesday, I have my ACT tutor and work tomorrow.
Okay. Okay. I could do 8:30. I can give you a half an hour tomorrow night. Do you want
what time?
8:30?
Tomorrow night?
Uh-huh.
Yeah, that works.
That works? Let me put you down there for that.
All right, so 8:30 tomorrow night.
Right.
Okay, perfect. Thank you so much.
Okay. I'll talk to you then.
All right, sounds good.
Okay. And it'll just be a half-hour session.
Okay, perfect.
All right.
All right.
All right.
Bye.